This video is a complete walkthrough of the RSTAR Affinity Field Utility app, covering the full process of commissioning, configuring, and verifying Affinity data logger and attached geotechnical instruments in the field. Within the Affinity system, the data from geotechnical instruments is collected by field loggers, transmitted wirelessly through a gateway, and made accessible via the cloud dashboard. The Field Utility app is the tool used on site to prepare that system for operation. In this walkthrough, you will learn how to manage your account, claim and configure a new data logger, pair it to a gateway, add and configure instruments, verify data, and manage ongoing maintenance tasks. The video also demonstrates offline workflows, cached actions, diagnostics, and support tools commonly used during field deployment. We will begin by downloading and launching the Field Utility app. Download the RSTAR Affinity Field Utility app from your phone's application store, which is App Store for iOS devices, and Google Play Store for Android devices. The support documentation mentioned in this video have been linked in the description box of this YouTube video. These documentation links will take the viewer to the Orica website. Once downloaded, open the app, grant Bluetooth and location permissions when prompted in the app. This is necessary to scan online instruments. Once permissions are granted, two platform options will appear: cloud or local server. Enter your unique domain name in the cloud server field and click Proceed. Follow the prompts to sign in to your RSTAR Affinity Field Utility account. After logging in, all accessible sites within your domain will be displayed. Select the site where the data logger needs to be claimed and deployed. Once selected, any loggers within Bluetooth range of your mobile device that are already online and active will appear. To power on and activate a new logger, pull the Battery tab. There may be one or more battery tabs present depending on the logger type. Their location can be seen here in these example images of loggers. Refer to the serial number on the side of the Affinity data logger unit. Use this number to identify and select the correct logger from the list of online devices shown on screen. Once the data logger is selected, the Claim Logger window appears. This window also provides general information about the logger, such as the serial number, module configuration, battery life, radio type, temperature, and region. In this window, the data logger can be claimed to this site by clicking the Claim button at the bottom. Claiming a logger means that any data synced from it, especially when operating in standalone mode, will be directed exclusively to that site's dashboard. After clicking Claim, the logger information window appears, allowing the user to assign a new name to the logger. Tap the GPS location button to set the latitude and longitude based on your device's location. These values will be displayed on the web dashboard and can be updated as needed. The manual adjustment via the browser-based dashboard can only be done after the logger has been initially claimed through the Field app. Reporting interval allows the user to set the reporting interval frequency from 5 minutes up to 24 hours depending on their energy usage and monitoring requirements. Initialize the batteries, which starts the battery counter at 100% using the fresh batteries provided with the unit. Click the Proceed button to finish claiming the logger. Once the logger has been claimed, it will be displayed on the map in the browser-based dashboard based on its initial GPS coordinates. To manually adjust these geographical coordinates of the data logger, log into our RSTAR Affinity dashboard using the credentials as set up by the RSTAR Affinity team. From the Device Overview menu in the left sidebar, go to Map and locate the online data logger that was just added in the previous step. Click on the data logger to expand the device details pop-up. Click on the logger's name to be taken into its instrument profile. Scroll down to the Location section, and manually enter the accurate coordinate values. Click Save to apply the edits. The data logger's initial screen view includes 3 main tabs: Profile, Instrument, and Monitor. Within the Profile tab, you'll see the general configuration and health status of the data logger, including battery life, firmware version, and module configuration. If needed, you can update the logger's name and GPS coordinates, latitude and longitude, after the initial claiming process. tap the arrow next to the logger's name to update the settings. In the Network section at the bottom of the Profile tab screen, you'll find the Pair Gateway button. This allows you to pair your data logger with any gateways that have been set up in your system via the web-based dashboard. Simply select the desired gateway from the list, and the data logger will pair with it, enabling two-way data transmission between the logger and the gateway. Once pairing is complete, your data logger will begin transmitting data wirelessly to the cloud and dashboard. The selected gateway's details can be seen populated under the Network settings. Tap the arrow next to the gateway's name to update the data logger's network settings. Details such as signal strength and LoRa settings can be accessed and altered. To optimize data transmission in poor signal areas, decrease the data rate in the LoRa settings to increase the spreading factor. This helps to improve range in areas with poor signal. If you're having trouble establishing a connection between the data logger and the gateway, you can also increase the number of retries. Conversely, if you have a strong connection and want to conserve battery life, you can reduce retries or increase the data rate. You can also toggle the transmit window, which adjusts the time frame during which the logger sends and receives data from the gateway within its reading interval. Once you've configured your desired settings, tap Save to apply them to the data logger. In the network settings, you can delete a gateway if you're replacing or removing it from the site. Check signal strength to assess connectivity on site. To add an instrument to a data logger, navigate to the Instrument tab and tap the Add Instrument button. This will open the Instrument Information window. In this example, we will configure a vibrating wire piezometer used for monitoring pore pressure measurements and water level. If you have access to the instrument's calibration sheet, simply click the QR code button beside Instrument Type. Scanning the instrument's QR code using your phone's camera will automatically populate the serial number, calibration, and temperature factor. Enter the instrument name. If the QR code cannot be found, enter the details manually by selecting the appropriate module type under the instrument type. Two types of modules are supported for instrumentation: Vibrating Wire and Thermistor module, or RS485 module, for digital bus instruments. The RSTAR Affinity single-channel vibrating wire data logger follows the same configuration process as the RSTAR Affinity data logger, with the only difference being that it requires configuration of a single channel instead of 5. Expand the drop-down arrow beside the appropriate module type to select the particular instrument type. In this example, we are adding and configuring a vibrating wire piezometer to the data logger. Enter a custom instrument name for easy identification and input the instrument's serial number, which can be found on the sticker attached to the instrument unit. Click Next Step to proceed, selecting the module which your instrument is configured to. Select the correct channel and sweep type for the instrument. The sweep type determines the range of frequency the data logger will be set to read. Different sensors have different natural frequencies, which determines which sweep type is needed to read the sensor. Tap Check Sensor to verify if the data logger is able to detect a signal from the sensor. An initial B-unit reading will appear with a green check mark, indicating successful sensor detection. After confirming sensor connectivity, tap the Next Step button at the bottom to continue. The associated thermistor settings appear. Select the required module, channel, and thermistor sensor type. The Steinhardt coefficients are auto-populated. Tap Check Sensor to perform a sensor check for the instrument's associated thermistor. The initial resistance value, in ohms, and the temperature, in degrees Celsius, appears on the screen, indicating proper thermistor functionality and reading. Tap the Next Step button. Enter the calibration configuration values, either linear or polynomial. At the bottom of the screen, tap the Take Reading button, which allows you to verify that the logger is capturing data correctly. If successful, the initial reading data will populate. Click Next Step to continue. In Site Information, you can change pressure, temperature, and frequency units on site to customize how they appear in the downloadable data file. Click on the next step to edit data labels. Here, you can modify data labels to suit your preferred column naming format. Click Next Step to continue. The location settings determine where the instrument is displayed on the web dashboard. If the coordinates are known, enter them manually, or you can automatically populate the latitude and longitude fields using your phone's GPS by clicking the location button next to these fields. The latitude, longitude, and elevation fields get populated. As mentioned previously, the accuracy of the coordinates depends on your mobile device GPS. If the coordinates are known, you can enter them manually in the browser-based dashboard after completing the claiming process in the app. You can also set the reading interval, ranging from 24 hours down to as little as 5 seconds. Checking Enable Advanced Interval Selection allows the user to configure the read interval from 5 seconds to 5 minutes. This is only recommended if necessary, as it will deplete the batteries quickly and will cause transmission errors for larger instruments such as ShapeArrays or long-in-place inclinometers. Once all the fields are configured, tap Complete to save the configuration of the instrument to your data logger and update it on the cloud server. This demonstration covers how to set up an in-place inclinometer, a commonly used digital instrument designed to reliably measure lateral movement in geotechnical applications, that connects via the RS-485 module. Navigate to the Instrument tab and tap the Add Instrument button. In the Instrument Information window, under Instrument Type, go to Digital Bus Module, RS-485, and select the instrument, which is vertical in-place inclinometer in this example. Enter the instrument name, and choose the correct module. After selecting the module, click Next Step and click Discover IPI to detect all IPI nodes on the communication bus. Once discovered, press Next Step to configure each node individually. Ideally, the serial numbers for each node will be auto-detected. Click on each node to go into the individual node settings. Ensure that the node name and serial number fields are populated. Use Check Sensor to verify functionality. Click Next Step to enter the node field properties for bay length and bottom wheel depth. Bay length refers to the distance between consecutive sensors along the inclinometer assembly. The bottom wheel depth for each sensor is the depth from the top of the borehole to the bottom wheel of that particular sensor. For the first or the bottommost sensor, the bottom wheel depth is equal to the borehole depth. The figure shows the bottom wheel depth for the first or bottommost sensor. These values are required for building a visual representation of the IPI chain in the dashboard's Visualization tab. This must be repeated for each node. Click Next Step to customize data labels for visualization if required. Click Complete to finalize the node configuration. Repeat this configuration process for each node. Once the IPI node setup is complete, take initial readings. The appearing updated nodes message confirms the successful initialization of IPI nodes. Click Next Step to apply the configuration to the sensors via the communication bus. After successful assignment, click Next Step to proceed to set displacement units and temperature units. Click Next Step to proceed to set location, via GPS, and other parameters. Set the reading interval, then tap Complete to configure the instrument to the data logger and server. The Affinity system also supports tilt loggers, which are designed specifically to measure tilt. The setup process is similar. Claim the logger to a site, assign a name and coordinates, set the reporting interval, and take initial readings. If the logger is already mounted, enable the Initial Readings option before proceeding. Most settings are the same as with other instruments. In the Instrument tab, select the preloaded tilt meter. You can take initial readings or enter them manually. Tap Next Step to continue. Use tilt thresholds to set warning or alarm levels based on tilt axis changes and tap Next Step. You can also configure a wake-up tilt level, which triggers a live reading if tilt exceeds a certain threshold, bypassing the regular reading interval. Once all settings are configured, apply them to the tilt logger and server. The final instrument configured in this demo is the vertical shape array, which measures near real-time deformation data and is connected using the RS-485 protocol. Navigate to the Instrument tab and tap Add Instrument button. In the Instrument Information window, under Instrument Type, go to Digital Bus Module RS-485 and select the instrument type, which is a vertical shape array in this example. Enter the instrument name and choose the correct module. After selecting the module, click Next Step. Under ShapeArray Settings, choose between Low Power Mode or Standard Mode. Check with your sales representative on the appropriate power mode for your ShapeArray. This will depend on project requirements. Then click Retrieve Settings to view configuration and health diagnostics. After confirming that all the values are correct, click Next Step to set site information parameters for reference point, casing size, azimuth offset, and more. Click Next Step to set the location values and reading interval, then click Complete to configure the instrument to the data logger and server. To validate readings, go to the Monitor tab and tap the Refresh button to take a live reading on each of the instruments configured to this particular data logger. The time required to register readings will depend on the instrument type and set reading interval value. Once readings are confirmed, the data logger and its connected instruments are successfully set up. Return to the data logger's main profile screen. In the bottom right corner, the Logger Options button provides additional features. Sync logger data allows the user to download data within a time window, download all new unsynced data, or download all data from the logger. This is useful if the gateway or logger has been offline or if a standalone system is being used. Return to the Profile tab and tap the Logger Options button to access other options from the menu. Diagnostic Report sends a JSON file to yourself or RST support for troubleshooting. Export Configuration saves the logger setup as a bin file so it can be transferred to a new logger. Import Configuration allows you to import a configuration file from a different logger onto the current logger as long as you have exported the configuration file onto your handheld device. This will automatically update the current data logger with the other data logger sensor configurations, calibration inputs, read intervals, and more. Unclaim Logger. The Unclaim Logger button removes the data logger from its current site so it can be reassigned to another site. Update Logger Firmware. Update Logger Firmware downloads the latest firmware, even if there is no network and the mobile device is offline. Set Logger Time. Syncs the logger's time if it has desynced. Initialize New Batteries. Resets the battery counter to 100% after replacing batteries. Reboot Logger. Restarts the logger if changes haven't been uploaded yet. In the bottom left corner, the More menu includes My Profile, updates your profile settings. Sites, returns to the previously visited sites. Manuals, access documentation for the Field app and RSTAR Affinity system. Log out, exits the app. View cached actions, use this when working offline. Cached actions are saved locally and can be synced once you're back online. If planning to work at a site with low or no connectivity, launch the app while you are still in a networked area with internet or cellular, and keep the app running throughout working at the site. Once you have connectivity again, go to View Cached Actions and send them to the cloud server by tapping the Send Cache button. There's also a shared debug log file, which may be requested by RST support for troubleshooting. The in-app navigation is easy, whether switching between different work sites or going into the configuration settings of a data logger, gateway, or instrument. Please contact RST support for further assistance if required. Once the Field app setup and configuration of data loggers and instruments is completed, the user can log out of their account.